Python is a popular and versatile general-purpose programming language. Here's a breakdown of its key characteristics. Strengths. Readability. Python code is known for its clear and concise syntax, often resembling natural language. This makes it easier to learn and understand, even for beginners with no prior programming experience. Versatility. Python can be used for a wide range of tasks, including web development, back-end frameworks like Django, data science and machine learning, libraries like NumPy, Pandas, scikit-learn, automation and scripting, system administration tasks, scientific computing, education and prototyping, large community and resources. Python boasts a vast and supportive community that provides extensive learning resources, tutorials, libraries, and frameworks. This wealth of material makes it easier to find help and explore different applications. Applications. Web development. Python frameworks like Django and Flask power many popular websites and web applications. Data science and machine learning. Python's rich ecosystem of libraries like NumPy, Pandas, scikit-learn, and TensorFlow makes it a go-to language for data analysis, machine learning, and artificial intelligence. Automation. Python scripts can automate repetitive tasks, system administration chores, and data processing workflows. Scientific computing. Python's powerful libraries like NumPy and SciPy cater to scientific computing needs, numerical computations, and data visualization. Overall, Python's ease of use, versatility, and extensive ecosystem make it a valuable skill for various fields and a great choice for those starting their programming journey. Here's a detailed explanation of the key differences between Python 2.x and Python 3.x. 1. Print statement. Python 2.x, print hello, world. Statement, no parentheses. Python 3.x, print hello, world. Function, requires parentheses. 2. Division. Python 2.x, integer division by default, e.g., 7/2 results in 3. Use float, x/y for true division. Python 3.x, true division by default, e.g., 7/2 results in 3.5. 3. Strings. Python 2.x, default string type is str, ASCII encoded. Use U-string for Unicode strings. Python 3.x, default string type is str, Unicode encoded. 4. Exception handling. Python 2.x, try, accept exception, e. Python 3.x, try, accept exception as e. Uses as for assigning the exception. 5. Range versus range. Python 2.x, range 10, creates an iterator for memory efficiency. Python 3.x, range 10, creates a list by default. Use itertools.count or custom generators for iterators. 6. Other differences. Input of function. In Python 2.x, row_input takes user input. In Python 3.x, input does the same. Global variables. More care is needed in Python 3.x to avoid unintended modifications of global variables within loops. Impact and considerations. Python 2.x reached end of life in 2020. Security patches and official support are no longer available. Python 3.x is actively maintained. It's the recommended version for new projects. Porting code from Python 2.x to 3.x can require effort due to these syntax and behavior changes. Tools and migration guides can help. In summary, Python 3.x offers a cleaner syntax, improved Unicode support, and a more consistent division behavior. It's the future-proof choice for new Python development. If you're working with legacy code, be aware of the differences and use appropriate methods for compatibility. There are two main ways to comment out multiple lines in Python. 1. Using the hash symbol, hashtag symbol. This is the most common and straightforward method. Simply place a hash symbol, hashtag symbol at the beginning of each line you want to comment out. Here's an example. Python. Hashtag this line is commented. In this example, the first two lines are commented out, while the last line will be executed when you run the code. 2. Using triple quotes, or. While not strictly for commenting out code, Python allows using triple quotes, either single quotes or double quotes, to create multi-line strings. Since these strings are not valid Python code, they effectively comment out the enclosed block. Here's an example. Python. This is a multi-line comment. It spans multiple lines using triple quotes. In this case, everything between the triple quotes is treated as a string and ignored during execution. This method is useful for longer comments or code sections you might want to temporarily disable without line-by-line commenting. Here's a quick comparison. Method use case. Hash symbol, hashtag symbol, a standard approach for commenting out multiple lines. Triple quotes, or large code blocks, temporary disabling of code. Additional tips. Some IDEs or text editors offer keyboard shortcuts for commenting and uncommenting lines of code. This can be a quick and efficient way to handle multiple lines. Remember that commented out code is still processed by Python, but it's not executed. This can be useful for debugging purposes, as you can comment out sections to isolate the problematic part. Python's popularity stems from its numerous advantages that make it a compelling choice for various programming tasks. Here's a breakdown of its key strengths. Readability and ease of use. Clear and concise syntax. Python code resembles natural language, making it easier to learn and understand, even for beginners with no prior programming experience. Focus on code readability. Python emphasizes code readability by using indentation and whitespace effectively, resulting in well-structured and maintainable code. Versatility and applicability. Wide range of applications. Python excels in various domains, including web development, Django, Flask, data science, NumPy, Pandas, scikit-learn, machine learning, TensorFlow, PyTorch, automation, scripting, and scientific computing. This versatility makes it a valuable skill for diverse fields. Large standard library. Python's extensive standard library provides built-in modules and functions for common tasks, reducing the need for external libraries in many cases. Development speed and productivity. Rapid prototyping. Python's concise syntax and clear readability enable rapid prototyping, allowing you to quickly test ideas and iterate on designs. High-level abstractions. Python abstracts away low-level details, letting you focus on the problem you're solving rather than the intricacies of system-level programming. Large and supportive community. Extensive resources. Python boasts a vast and active community that provides a wealth of learning resources, tutorials, libraries, and frameworks. This comprehensive support system makes it easier to find help and explore different applications. Open source nature. Python's open source foundation fosters collaboration and ongoing development, ensuring a continuous stream of improvements and innovations. Additional advantages. Cross-platform compatibility. Python code can run on various operating systems, Windows, macOS, Linux, with minimal or no modifications. Easy memory management. Python handles memory management automatically, freeing you from the complexities of manual memory allocation and deallocation. In conclusion, Python's ease of use, versatility, extensive libraries, large community, and open-source nature make it a powerful and preferred choice for programmers of all levels. Whether you're a beginner starting your coding journey or an experienced developer seeking a productive and versatile language, Python offers a compelling value proposition. There are two primary methods to check the installed Python version on your system, regardless of whether you're using Windows, macOS, or Linux. 1. Using the command line. Open a command prompt or terminal window. Type the following command and press Enter. Bash. Python version hashtag or python-webdev. This command will display the installed Python version information, typically including the major, minor, and micro version numbers, e.g., Python 3.10.8. 2. Using Python shell, optional. Open a command prompt or terminal window. Type the following command and press Enter. Bash. Python. This will launch the Python interactive interpreter. Once in the interpreter, you can type the following command and press Enter to see the version information. Python. Import sys. Print sys.version. This code snippet imports the sys module and then prints the version information stored in the sys.version variable. Additional notes. If you have multiple Python versions installed, the specific command used to launch the interpreter, e.g., Python 3 for Python 3, might be different. You can check your system's documentation or use your environment manager, like pyenv or virtualenv, to determine the correct command. The Python version or python-webdev method is generally more reliable and straightforward, as it checks the system-wide Python installation. PEP 8, sometimes spelled PEP 8 or PEP 8, stands for Python Enhancement Proposal 8. It's a style guide that outlines coding conventions for writing clean, consistent, and readable Python code. Here's a breakdown of its key aspects. Purpose. Promotes code readability and maintainability across different projects and development teams. Ensures consistency in style, making it easier for programmers to understand and collaborate on Python code. Serves as a reference for automatic code formatters and linters, improving code quality and reducing errors. Key guidelines. Indentation, uses 4 spaces per indentation level instead of tabs for better clarity. Whitespace, employs consistent whitespace around operators, after commas, and within parentheses to enhance readability. Naming conventions, recommends using lowercase with underscores for variable and function names, and camel case for class names. Line length, advises limiting lines to a maximum of 79 characters, can be adjusted based on project or coding style preferences. Docstrings, encourages using docstrings, multi-line comments, to document functions, classes, and modules. Imports, provides guidelines for organizing and formatting import statements for clarity. Comments, recommends writing clear and concise comments to explain complex logic or non-obvious code sections. Benefits. Improved code readability and maintainability for both individual developers and teams. Reduced potential for errors and bugs due to consistent style and formatting. Easier collaboration and code matching potential issues. In Python, a package is a container that organizes related Python modules, .py files to promote code reusability, maintainability, and modularity. Here's a breakdown of the key concepts. Modules versus packages. Modules, individual Python files containing functions, classes, and variables that you can import and use in your programs. Packages, collections of modules that are typically related by functionality or domain. A package acts as a directory that holds these modules and often includes an initialization file named __init__.py, can be empty or contain initialization code. Benefits of using packages. Organization. Packages help you organize your code into logical units, making it easier to manage and maintain large projects. Reusability. You can reuse code across different projects by importing modules from the package. Namespace management. Packages provide a way to avoid naming conflicts between functions and variables in different modules. Structure of a package. Package _name / _init__.py, optional initialization code. Module1.py. Module2.py. Subpackage /# can contain nested subpackages. __init__.py. Another _module.py. Importing modules from a package. To import a module from a package, you use the import statement followed by the module name within the package structure, separated by dots. Here's an example. Python. Import package _name.module1. #access functions or variables from module 1. Package _name.module1.function_name. You can also import all modules from a package using from package _name import *, but this is generally discouraged as it can lead to naming conflicts. Installing third-party packages. Python offers a rich ecosystem of third-party packages for various functionalities, data science, web development, machine learning, etc. You can install these packages using the pip package manager, which comes bundled with most Python installations. By effectively using packages, you can structure your Python code in a clean, organized, and reusable manner, enhancing your development experience and code quality. Executing a Python script from the command line involves two key steps. 1. Navigate to the directory. Open a command prompt or terminal window. Use the cd command to change directories and reach the location where your Python script is saved. For example, if your script is named hello.py and it's located on your desktop, you might use the following command. Bash cd desktop. 2. Run the script. Once you're in the correct directory, type the following command and press enter. Bash python script _name.py. Replace script _name.py with the actual file name of your Python script. Additional considerations. Python version. If you have multiple Python versions installed, you might need to specify the exact version you want to use. For example, to run the script using Python 3, you could use bash python 3 script _name.py. Script location. If your script is located in a directory that's not included in your system's path environment variable, you'll need to provide the full path to the script instead of just the file name. For example, bash python/home/user/project/my_script.py. Here are some helpful tips. Make sure your Python script has the .py extension. Ensure that the Python interpreter is installed and accessible from the command line. Double-check for any typos in the script file name or the command you're typing. In Python, both lists and tuples are used to store collections of items, but they differ in terms of mutability and use cases. Here's a breakdown of the key distinctions. Mutability. List. Mutable lists are dynamic, meaning you can modify their contents after creation. You can add, remove, or change elements within a list. This flexibility makes them suitable for situations where you need to update the data collection. Tuple. Immutable tuples are static, meaning their contents cannot be changed once created. You cannot add, remove, or modify elements after defining a tuple. This immutability ensures data integrity and makes them useful for representing fixed datasets or configurations. Syntax. List. Lists are enclosed in square brackets, and elements are separated by commas. Python. My_list equals 1 apple 3.14. Tuple. Tuples are defined using parentheses, and elements are also separated by commas. In some cases, you can omit the parentheses for a single element tuple, but it's generally recommended for clarity. Python. My_tuple equals 2 banana true. My_tuple equals 4 hashtag single element tuple with trailing comma. Use cases. Lists. Use lists when you need a collection of items that might change over time. For example, storing shopping lists, student grades, or tracking inventory levels. Tuples. Use tuples when you need a fixed collection of data that shouldn't be modified. Examples include coordinates, representing geometrical points, or configuration settings. Tuples are also often used as dictionary keys because their immutability guarantees they won't be changed. Additional considerations. Tuples are generally faster and more memory efficient than lists because they don't require the overhead of managing mutability. Both lists and tuples support indexing and slicing to access or extract elements. Here's a table summarizing the key differences. Feature list tuple. Mutability. Mutable can be changed after creation. Immutable cannot be changed after creation. Syntax, square brackets, parentheses. Use cases, changeable collections, fixed, unmodifiable collections. Performance slower, more memory overhead, faster, more memory efficient. Example, 1 apple 3.14, a 2 banana true. By understanding these differences, you can choose the appropriate data structure, list or tuple, for your specific needs in your Python programs. In Python, equals and is are both comparison operators, but they address different concepts. 1 == equality operator. Checks for value equality. Two objects are considered equal if they have the same value. Commonly used for comparing data types like integers, strings, floats, booleans, or even lists or dictionaries with the same content. Example: x = 5. Y = 5. Print x == y, #output, true, x and y have the same value. Name 1 = Alice. Name 2 = Alice. Print, name 1 = name 2, #output, true, strings have the same content. List 1 = 1, 2, 3. List 2 = 1, 2, 3. Print, list 1 = list 2, #output, true, lists have the same elements. 2 is identity operator. Checks for object identity. Two objects are considered identical if they refer to the same memory location, the same object in memory. Useful for comparing simple data types, integers, strings, etc., created at the same time, or objects specifically designed to be singletons. Example: x = 5. Y = 5. Print x is y, #output, true, x and y refer to the same integer object. Name 1 = Alice. name2 equals Alice. Print, name1 is name2, hashtag output, true. Both strings might refer to the same object in memory if optimized. List1 equals 1, 2, 3. List2 equals 1, 2, 3. Print, list1 is list2, hashtag output, false. Even though they have the same content, they are separate objects. Key points. Use equals equals for value equality comparisons in most cases. Use is for object identity checks, especially with simple data types or singletons where you want to ensure they are the exact same object. Be aware that Python might optimize small integer and string objects, so as might return true even for different variable assignments in some cases. This behavior can change depending on Python version and optimization settings. Python offers a variety of fundamental data types that serve as the building blocks for storing and manipulating information in your programs. Here's a breakdown of the most common ones. 1. Numbers. Integers, int represent whole numbers, positive, negative, or 0, e.g., -5, 0, 10, 24. Floats, float represent decimal numbers, e.g., 3.14, -9.25, 1.0. Complex numbers, complex represent numbers with a real and imaginary part, e.g., 3 plus 5j, where j represents the imaginary unit. 2. Strings, str. Represent sequences of characters enclosed in single or double quotes. Can contain letters, numbers, symbols, and white space. 3. Booleans, bool. Represent logical values, true or false. Used for conditional statements and representing true/false conditions. 4. Sequences. Lists, list-ordered, mutable collections of elements enclosed in square brackets. Elements can be of different data types. You can add, remove, or modify elements after creation. E.g., 1, hello, 3.4. Tuples, tuple-ordered, immutable collections of elements enclosed in parentheses. Elements can be of different data types. Tuples cannot be changed after creation. E.g., 2, world, true. 5. Sets, set. Unordered collections of unique elements enclosed in curly braces. Elements must be immutable, e.g., strings, numbers. Sets don't allow duplicates and provide methods for efficient membership testing and set operations. 6. Dictionaries, dict. Unordered collections of key-value pairs enclosed in curly braces. Keys must be immutable and unique, while values can be any data type. Dictionaries provide efficient access to elements using their keys. E.g., name Alice, age 30. 7. None. A special data type representing the absence of a value. It's often used as a placeholder or to indicate that a variable doesn't hold any data. By understanding these basic data types and their functionalities, you can effectively store, manipulate, and organize data within. 1. Using the open function. The primary way to open a file in Python is using the built-in open function. This function takes two arguments. File name, the name or path of the file you want to open. Mode, optional, a string specifying the mode in which you want to open the file. Common modes include R, open for reading, default. W, open for writing, existing content will be overwritten. Open for appending, new data will be written to the end of the existing content. R+, open for both reading and writing. Here's an example of opening a file for reading. Python. F equals open, myfile.txt, R, hashtag open, myfile.txt, in read mode. 2. Using the with statement. It's generally recommended to use the with statement when working with files in Python. The with statement ensures that the file is automatically closed even if an exception occurs during processing. Here's the same example using with. Python. With open myfile.txt r as f. Hashtag read the contents of the file. Content equals f.read. Hashtag do something with the content. Print content. 3. Reading the file contents. Once you have opened the file, you can use various methods to access its contents. f.read reads the entire content of the file as a string. f.readline reads a single line from the file and returns it as a string, including the new line character. f.readlines reads all lines from the file and returns them as a list of strings. Each line is an element in the list. 4. Writing to a file. If you open the file in write mode, W, you can use the f.writeData method to write data to the file. The data argument should be a string containing the content you want to write. 5. Closing the file. When you're finished working with the file, it's important to close it explicitly, if you're not using the with statement. You can do this using the f.close method. Remember, make sure the file you're trying to open exists in the same directory as your Python script or provide the full path to the file. Choose the appropriate mode, R, W, or R+, based on your intended operation, reading, writing, appending, or both reading and writing. Use the with statement for improved file handling and automatic closing. By following these steps, you can effectively open, read, write, and close files in your Python programs. Here's a breakdown of the key differences between lists and dictionaries in Python. Lists. Ordered collection. Elements are stored in a specific order and accessed using numerical indexes, starting from 0. Duplicates allowed. Lists can contain duplicate elements. Heterogeneous. Lists can hold elements of different data types, e.g., strings, integers, floats. Use cases. Lists are ideal for storing sequences of data representing items in a specific order, e.g., shopping list, task list. Example. Fruits equals apple, banana, orange, apple, hashtag duplicate apple allowed. Numbers equals 1, 3.14, 5, hashtag different data types, int, float. Dictionaries. Unordered collection. Elements are not stored in a specific order. They are accessed using unique keys. Unique keys. Keys must be unique and immutable, e.g., strings, numbers, tuples. Values can be duplicated. Heterogeneous. Dictionaries can have keys of one data type and values of another, e.g., string keys, integer values. Use cases. Dictionaries are ideal for storing key-value pairs, where you need to associate data with unique identifiers, e.g., phonebook, user data with name and email. Example. Person equals name Alice, age 30, city New York, hashtag unique keys, name, age, city. Key differences table. Feature lists dictionaries. Order ordered unordered. Duplicates allowed not allowed for keys as values can be duplicated. Data types heterogeneous keys, typically immutable, strings, numbers, tuples as values, heterogeneous. Accessing data by numerical index, starting from 0, by unique key. Use cases sequences of data, items in specific order key-value pairs, data with unique identifiers. Choosing between lists and dictionaries. If you need to preserve the order of elements and allow duplicates, use a list. If you need to associate data with unique identifiers and don't care about the order, use a dictionary. There are two main ways to create an empty dictionary in Python. 1. Using curly braces. This is the most common and concise way to create an empty dictionary. You simply enclose an empty pair of curly braces with no elements inside. Empty_dict equals 2. Using the dict function. While less common for empty dictionaries, you can also use the built-in dict function without any arguments. Empty_dict equals dict. Both methods result in an empty dictionary named empty_dict in this example. You can then use various methods to add key value pairs to the dictionary. Empty_dict, key 1 equals value 1. Empty_dict, key 2 equals 10. Here's a table summarizing the approaches. Method example. Curly braces empty_dict equals dict function empty_dict equals dict. Sets and frozen sets in Python are both used to store collections of unique elements, but they have a key difference in mutability. Sets. Mutable elements can be added, removed, or modified after creation. Unordered elements are not stored in a specific order. Accessing elements by index is not possible. Use cases. When you need to store unique elements and need the flexibility to modify the collection. Examples include removing duplicates from a list, checking for membership, or performing set operations, union, intersection, difference. Example. Python. My_set equals 1 apple 3.14 hashtag elements of different data types. My_set to add banana hashtag adding an element. My_set remove 1 hashtag removing an element. Use code with caution. Content_copy. Frozen sets. Immutable elements cannot be added, removed, or modified after creation. Unordered, similar to sets, elements are not stored in a specific order. Use cases. When you need a read-only collection of unique elements. This ensures data integrity and prevents accidental modifications. Frozen sets are also hashable, making them suitable for use as dictionary keys or elements within other sets. Example. Python. My_frozen set equals frozen set 10 orange 2.7. Hashtag my_frozen set to add grape. Hashtag this will cause a type error. Hashtag frozen sets are hashable. My_dict equals my_frozen set. This is a key. Use code with caution. Content_copy. Choosing between sets and frozen sets. Use a set if you need to modify the collection of elements. Use a frozen set if you need a read-only collection and want to ensure data integrity or use it as a key in a dictionary. Additional points. Frozen sets are typically more memory efficient than sets because they are immutable and don't require the overhead of managing potential modifications. You can convert a set to a frozen set using the frozen set function. In summary, both sets and frozen sets offer unique features for handling collections of unique elements. Choose the appropriate one based on your need for mutability and how you intend to use the collection in your Python program. There are two main ways to convert a string to a list in Python, depending on whether you want to split the string into individual characters or into words/substrings based on a delimiter. 1. Converting to a list of characters. Use the list function with the string as the argument. This creates a list where each element is a single character from the string. My_string equals hello. Char_list equals list, my_string. Print, char_list, hashtag output, HELLO. 2. Converting to a list of words/substrings, splitting. Use the split method of the string object. This method splits the string into a list of substrings based on a specified delimiter, separator. By default, it splits on any whitespace character, space, tab, new line, etc. My_string equals, this is a sentence. Word_list equals my_string.split. Print, word_list, #output, this is a sentence. #splitting with a custom delimiter, comma in this case. My_string equals, apple, banana, cherry. Fruit_list equals my_string.split, comma. Print of fruit_list, #output, apple, banana, cherry. Key points. The list method treats the entire string as an iterable, creating a list with each character as an element. The split method splits the string based on the delimiter, resulting in a list of substrings. You can customize the delimiter in the split method by providing a string argument. Choosing the right method. Use list, my_string, if you want each character of the string as a separate element in the list. Use my_string.split, if you want to split the string into words or substrings based on a delimiter. The none keyword in Python serves a specific purpose, representing the absence of a value. It's not the same as an empty string, false, or 0. Here's a detailed explanation of its role and usage. Understanding none. Data type, none is a singleton object of the none_type class. This means there's only one none object in existence for the entire Python interpreter session. Meaning, none signifies the lack of a value. It's used to indicate that a variable doesn't hold any data or that a function doesn't explicitly return anything. Common use cases. 1. Initializing variables. You can use none to assign a placeholder value to a variable, indicating it doesn't have a meaningful data yet. Later, you can assign an actual value to it. X equals none #variable X initially has no value. X equals 10 #later, X is assigned the value 10. Function return values. If a function doesn't explicitly return a value using return, Python implicitly returns none. This is helpful when a function performs an action but doesn't necessarily need to produce a specific output. Def greet. Print, hello. Result equals greet, #greet, doesn't return anything explicitly, so result is none. Method return values. Similar to functions, methods can also return none if they don't have a specific value to return. 2. Indicating missing values. None is often used in data structures like dictionaries or lists to represent missing or absent entries for a particular key or index. My_dict equals, name Alice, age, none, #age, has no value assigned yet. Conditional statements. You can use none in conditional statements, like if or is, to check if a variable has no value assigned. If X is none. Print, X has no value. Key points. None is not the same as an empty string, false, or 0. It specifically represents the absence of a value. You cannot modify none by assigning a new value to it. There's only one none object. Use none judiciously to represent the lack of a value and avoid potential errors caused by unexpected data. In summary, the none keyword in Python is a fundamental concept for handling the absence of values. By understanding its purpose and usage effectively, you can write cleaner, more robust Python code. In Python, a generator is a special type of function that returns an iterator. Unlike a regular function that returns a single value, a generator yields a sequence of values on demand. This makes them memory efficient when dealing with large or infinite sequences. Here's a breakdown of the concept. 1. Using the yield keyword. Generators use the yield keyword instead of return to produce a sequence of values. The function execution pauses at each yield statement, and the generator remembers its state, local variables, between calls. Def my_generator. for I in range of 5. Yield I asterisk 2 hashtag yielding values on demand. Hashtag calling the generator function doesn't execute the code yet. My_gen equals my_generator. Hashtag to get the next value, use the next function on the iterator. Print, next, my_gen, hashtag output, 0. Print, next, my_gen, hashtag output, 2. Hashtag, and so on. 2. Generator expressions, similar to list comprehensions. Similar to list comprehensions for creating lists, you can use generator expressions to create generators in a concise way. They use parentheses instead of square brackets. Hashtag generator expression for squaring numbers. Even_squares equals x asterisk x for x in range of 4. Hashtag accessing elements using a loop, similar to lists. For number in even_squares. Print, number, hashtag output, 0416. 3. Benefits of generators. Memory efficiency. Generators are ideal for large or infinite sequences because they don't create the entire sequence in memory at once. They yield values one at a time. Lazy evaluation. The calculation happens only when the next value is requested, improving efficiency for complex operations. 4. When to use generators. Processing large datasets where storing everything in memory is impractical. Creating infinite sequences, e.g., for prime numbers. Implementing custom iterators for your data structures. In summary, generators provide a powerful and memory-efficient way to work with sequences in Python. By understanding how they yield values and their benefits, you can write more efficient and elegant code for various scenarios. Tuple unpacking in Python is a concise and powerful way to assign multiple values from a tuple to individual variables in a single line. It's particularly useful when working with functions that return multiple values or iterating over elements in a tuple. Here's a detailed explanation of tuple unpacking. 1. Basic unpacking. Imagine you have a tuple containing multiple elements. My_tuple equals apple, banana, cherry. You can unpack this tuple into individual variables using the same number of variables on the left side of the assignment operator. Fruit 1, fruit 2, fruit 3 equals my_tuple. Print fruit 1, hashtag output, apple. Print fruit 2, hashtag output, banana. Print fruit 3, hashtag output, cherry. In this example, each variable on the left-hand side, fruit 1, fruit 2, fruit 3, corresponds to an element in the tuple on the right-hand side, my_tuple. The values are assigned in the same order they appear in the tuple. 2. Unpacking with extended sequences. What if you have a tuple with more elements than variables for unpacking? Here, Python provides options. Partial unpacking. Unpack only the desired elements, leaving the remaining ones in a new variable. Fruits. Color equals my_tuple, 2, my_tuple, 2, hashtag unpack first 2 elements and the third into separate variables. Print of fruits, hashtag output, apple, banana. Print, color, hashtag output, cherry. Discarding elements, use __ to discard unwanted elements while unpacking. First _fruit, *_ equals my_tuple. Print of first _fruit, hashtag output, apple. Hashtag the remaining elements are discarded. 3. Unpacking with short tuples. If the tuple has only one element, directly assigning it to a variable is equivalent to unpacking. My_tuple equals orange, hashtag tuple with a single element. Fruit equals my_tuple hashtag assigning the entire tuple, not unpacking. Hashtag or. Fruit equals my_tuple hashtag unpacking the single element. print of fruit, #output, orange, both approaches work. For unpacking in loops and iterations. Tuple unpacking is often used with for loops to iterate over elements in a tuple and assign them to variables. Fruits equals mango, grape, watermelon. For fruit, index in enumerate, fruits #unpacking with enumerate for index. Print f, fruit at index is fruit. Benefits of tuple unpacking. Readability makes code more concise and readable, especially when dealing with multiple values. Efficiency avoids the need for multiple assignment statements. In summary, tuple unpacking is a versatile feature in Python that allows you to efficiently assign multiple values from a tuple to individual variables. Understanding how to use it effectively can improve the clarity and efficiency of your Python code. Both if and elif, else if, are conditional statements used for making decisions in Python code. However, they differ in how they are evaluated and executed. 1. If statement. The if statement evaluates a condition. If the condition is true, the code block indented under the if statement is executed. If the condition is false, the code block is skipped, and the program continues to the next line of code. You can have multiple if statements chained together to check for different conditions. Python. X equals 10. If x greater than 5. Print x is greater than 5. Else. Print x is less than or equal to 5. Use code with caution. Content_copy. 2. Elif statement. The elif statement is used in conjunction with an initial if statement to create a multi-way branch. It's essentially an else-if condition. The elif statement is only evaluated if the condition in the previous if statement was false. It allows you to check for additional conditions after the initial if check. You can have multiple elif statements chained together to define multiple branches based on different conditions. Python. X equals 3. If x greater than 5. Print x is greater than 5. Elif x greater than 0. Print x is between 1 and 5. Else. Print x is less than or equal to 0. Use code with caution. Content_copy. Key differences. Order, if statements are evaluated sequentially from top to bottom. An elif statement is only checked if the preceding if statements were false. Execution, only one block of code, from if, elif, or else, is executed based on the first true condition encountered. Choosing between if and elif. Use if for a single condition and separate code execution based on whether it's true or false. Use elif when you have multiple conditions to check after an initial if statement has been evaluated as false. You can chain multiple elif statements to create a sequence of conditional checks. Example. Python. Grade equals 85. If grade greater than or equal to 90. Print excellent. Elif grade greater than or equal to 80. Print very good. Elif grade greater than or equal to 70. Print good. Else. Print needs improvement. Use code with caution. Content_copy. In this example, the if statement checks for an excellent grade. If not, the first elif checks for a very good grade, and so on. Only the first condition that evaluates to true will trigger its corresponding code block. By understanding the distinction between if and elif, you can write more efficient and well-structured conditional logic in your Python programs. The for loop is a fundamental control flow statement in Python used for iterating over a sequence of items. It allows you to execute a block of code repeatedly for each element in the sequence. Here's a detailed explanation of for loops in Python. 1. Syntax. Python. For item in sequence. Hashtag code to be executed for each item. Item. This represents a variable name that will hold the current element from the sequence during each iteration of the loop. You can choose any valid variable name. Sequence. This can be any iterable object like a list, tuple, string, dictionary, with keys, or any object that can be used with the iter function to create an iterator. 2. How it works. 1. The for loop statement is encountered. 2. The sequence is evaluated to get an iterator object. 3. The loop continues as long as there are elements remaining in the iterator. 4. In each iteration, the next element from the iterator is assigned to the item variable. The code block indented under the for statement is executed using the current value of item. 5. The loop continues to step 4 until there are no more elements in the iterator. 3. Example. Python. Fruits equals apple, banana, cherry. For fruit in fruits. Print or fruit. This code will print each fruit, apple, banana, cherry, on a new line. 4. Loop control statements. Break. This statement terminates the loop prematurely and exits the loop entirely. Continue. This statement skips the current iteration of the loop and jumps to the next iteration. 5. Looping with indexes. You can also use the enumerate function to get both the index and the element during each iteration. Python. Fruits equals apple, banana, cherry. For index, fruit in enumerate, fruits. Print f, fruit at index is fruit. This code will print the index and the corresponding fruit for each element in the list. 6. Looping over dictionaries. While looping through dictionaries, by default, the for loop iterates over the keys. If you want to access the values, you can use the items method. Python. My_dict equals name Alice, age 30. For key, value in my_dict the items. Print f, key, value. This code will print each key value pair from the dictionary. 7. Nested loops. You can have for loops nested inside other loops to iterate over multi-dimensional sequences, like lists of lists. Python. For I in range, 2. For j in range, 3. Print f, I, j. This code will print all possible combinations of coordinates within a 2x3 grid. In summary, the for loop is a versatile tool for iterating over sequences in Python. By understanding its syntax, control statements, and how to use it with different data structures, you can write efficient and readable code for various tasks. There are two primary ways to terminate a loop prematurely in Python. 1. Using the break statement. The break statement immediately exits the loop entirely, regardless of whether the loop condition is still true or not. Once break is executed, control jumps to the statement following the entire loop block. Python. Fruits equals apple, banana, cherry, orange, mango. For fruit in fruits. If fruit equals orange. Print f, found, fruit, stopping the loop. Break. Print or fruit. This code will print apple, banana, cherry, and then found orange, stopping the loop before exiting the loop. 2. Using the continue statement. The continue statement skips the current iteration of the loop and jumps to the beginning of the next iteration. The loop condition is re-evaluated, and if it's still true, the loop continues with the next element. Python. Numbers equals 1, 2, 3, 4, 5, 6. For number in numbers. If number %2 equals 0, hashtag skip even numbers. Continue. Print number. This code will only print the odd numbers, 1, 3, 5, because it skips even numbers using continue. Choosing between break and continue. Use break when you want to completely exit the loop as soon as a specific condition is met. Use continue when you want to skip the current iteration and move on to the next element in the sequence, but still intend to complete the loop eventually. Additional considerations. While break and continue provide flexibility, overuse can make code harder to read. Consider using well-defined loop conditions or alternative loop constructs, e.g., list comprehensions, for simpler termination logic. Be mindful of infinite loops. If your loop condition never becomes false, the loop will continue indefinitely. Always ensure your loop has a clear termination path. By effectively using break and continue, you can control the flow of your loops in Python and write more efficient code for various scenarios. Both break and continue statements are used for loop control in Python, but they serve different purposes. 1. Break statement. Function terminates the loop entirely, regardless of the loop condition. Behavior: once break is executed within a loop iteration, the loop exits immediately. Control jumps to the statement following the entire loop block. Use case: suitable when you want to prematurely stop the loop upon meeting a specific condition. Example: Python. Numbers equals 1, 5, 2, 8, 3. For number in numbers. If number of 5. Print f, found a number greater than 5, number. Break. Print number. This code will print 1, 5. Found a number greater than 5, 8. The loop stops iterating after encountering 8, greater than 5, because of the break statement. 2. Continue statement. Function skips the current iteration of the loop and jumps to the beginning of the next iteration. Behavior: the loop condition is reevaluated. If it's still true, the loop continues with the next element in the sequence. Use case: useful when you want to disregard the current element and proceed to the next iteration based on a specific condition. Example: Python. Letters equals A, B, C, D, E. For letter in letters. If letter equals C. Continue hashtag skip is C. Print letter. This code will print A, B, D, E. The loop skips a C using continue and continues iterating through the remaining letters. Key differences. Feature break statement, continue statement. Action terminates the entire loop, skips the current iteration. Control flow jumps out of the loop block, jumps to the next iteration. Loop condition doesn't affect remaining loop reevaluated before next iteration. Choosing the right statement. Use break when you only care about a specific condition and want to exit the loop as soon as it's met. Use continue when you want to handle specific elements differently, like skipping them, but still intend to iterate through the entire sequence. In summary, by understanding the distinctions between break and continue, you can effectively control the flow of your loops in Python, making your code more concise and efficient for various tasks. Remember, using these statements excessively can make code harder to read. Consider alternative loop constructs or well-defined conditions for simpler termination logic when applicable. The pass statement in Python serves a specific purpose, acting as a placeholder within your code. It essentially tells the Python interpreter to do nothing when it encounters the pass statement. Here's a detailed explanation of its use cases. 1. Maintaining code structure. Pass is often used as a placeholder within control flow statements, like if, elif, for, while, or function definitions to maintain proper code structure. This allows you to write the overall structure of your code first and then fill in the functionality later. Example: Python def greet name. If name, hashtag placeholder for a condition to check if name is provided. Pass hashtag placeholder for the actual greeting logic. Else, pass hashtag placeholder for handling the case where no name is provided. Hashtag you can later come back and implement the actual logic within these placeholders. 2. Preventing syntax errors. In some cases, Python syntax requires a statement but doesn't necessarily require an action at that specific point. Using pass prevents syntax errors while keeping the code structure valid. Example: Python hashtag empty class definition, no attributes or methods yet. Class my class. Pass hashtag empty function with a docstring, no implementation yet. Def my underscore function. This function does something, to be implemented later. Pass. 3. Looping without functionality. While uncommon, you can use pass within loops to create an empty loop that iterates but doesn't perform any specific action within each iteration. Example: Python hashtag looping 5 times without doing anything in each iteration. For I in range of 5. Pass. 4. Denoting unreachable code. Pass can be used in unreachable code blocks, e.g., after a return statement, to improve code readability and avoid potential warnings from linters. Example: Python def always underscore returns underscore 5. Return 5. Pass hashtag this line is unreachable because the function already returns from the previous line. Key points: pass itself doesn't perform any action or calculation. Use pass judiciously to maintain code structure and avoid syntax errors while keeping your intentions clear. Overusing pass can make code less readable. Aim for well-defined conditions and functionality within your code blocks whenever possible. In summary, the pass statement is a simple but useful tool in Python for maintaining code structure, preventing syntax errors, and acting as a placeholder for future functionality. By understanding its use cases, you can write cleaner and more maintainable Python code.
Both break and continue statements are control flow statements in Python that modify how loops, like for and while, iterate. However, they differ in how they affect the loop's execution. 1. Break statement. Function terminates the loop entirely. Behavior: when a break statement is encountered inside a loop, the loop's execution stops immediately. Any remaining code within the loop body is skipped, and control jumps to the statement after the loop. Example: Python numbers equals 1, 2, 3, 4, 5 for number in numbers. If number equals 3, print f found number, breaking the loop. Break print number. Output 1, 2, found 3, breaking the loop. In this example, the loop iterates through the numbers. When it reaches 3, the break statement is executed, terminating the loop and printing the message. The loop doesn't print 4 or 5. 2. Continue statement. A function skips the current iteration and moves to the next one. A behavior: when a continue statement is encountered inside a loop, the remaining code within the current iteration is skipped. However, the loop doesn't terminate. Control jumps back to the beginning of the loop, and the next iteration starts. Example: Python numbers equals 1, 2, 3, 4, 5 for number in numbers. If number %2 equals 0, hashtag check for even numbers. Continue. Print number. Output 1, 3, 5. In this example, the loop iterates through the numbers. If the number is even, the continue statement is executed, skipping the print statement for that iteration. The loop then moves to the next odd number and continues printing. Key points. A break exits the entire loop, while continue skips the current iteration and continues looping. A break is often used when you find what you're looking for within the loop and want to stop iterating further. A continue is often used to filter out specific conditions within the loop and only process desired elements. Choosing between break and continue. The choice between break and continue depends on your program's logic. Use break when you want to exit the loop after a specific condition is met. Use continue when you want to skip certain iterations based on a condition and continue looping for the remaining elements. The pass statement in Python is a null statement, meaning it does nothing and has no effect on the program's execution. It's primarily used as a placeholder in various contexts. 1. Unimplemented functionality. When you're defining a function, class, or loop structure but haven't yet implemented the actual code, you can use pass as a placeholder. Python. Def greet name. Hashtag placeholder for future implementation. Pass. Class animal. Hashtag placeholder for future attributes and methods. Pass. For I in range 5. Hashtag placeholder for code to be executed in each iteration. Pass. These pass statements indicate that the code block exists but is currently empty. They help maintain code structure and readability while you're developing or leaving functionality for later implementation. 2. Required syntax but no action needed. In some control flow statements like if, elif, or else, Python requires a statement even if no action is necessary. Here, pass is useful. Python. X equals 10. If x greater than 5. Hashtag do something if x is greater than 5. Pass. Elif x less than 0. Hashtag do something if x is less than 0. Pass. Else. Hashtag do something if x is between 0 and 5, optional. Pass. The pass statements in the elif and else blocks indicate that these blocks exist but currently have no code to execute. 3. Loop iterations, less common. In rare cases, you might use pass within a loop iteration to explicitly indicate that no action needs to be taken for that specific iteration. Python. For item in data. If some_condition item. Hashtag process the item. Pass hashtag placeholder for future processing logic. Else. Pass hashtag do nothing for this iteration. Key points. A pass doesn't cause errors or affect program behavior. It simply serves as a placeholder or an empty statement. It helps maintain code structure and readability, especially when you're planning future functionality or dealing with conditional blocks that might be empty. Alternative to pass, rare cases. In some situations, you might consider using comments, lines starting with hashtag, to explain why a code block is empty. However, pass is generally preferred for clarity and consistency. In summary, the pass statement is a versatile tool in Python for indicating empty code blocks, maintaining structure, and preventing syntax errors when a statement is syntactically required but no action is necessary. Exception handling in Python is a crucial mechanism for managing errors that may arise during program execution. It allows you to write robust and maintainable code by gracefully handling unexpected situations. Here's a detailed breakdown of exception handling in Python. 1. The try, except block. The core concept of exception handling involves the try, except block. The try block contains the code you expect to execute normally. The except blocks handle exceptions that might be raised within the try block. Python. Try. Hashtag code that might raise an exception. Result equals 10/0 hashtag this will cause a 0 division error. Print result. Except 0 division error. Print, oops. You can't divide by 0. In this example, the try block attempts to perform a division by 0, which will raise a 0 division error. The except block catches the zero division error and prints a custom message. 2. Catching specific exceptions. You can specify the type of exception to catch within the except block. Python. Try. Number equals int, input, enter a number. Except value error. Print, invalid input. Please enter a number. Here, the except block specifically handles value error which might occur if the user enters a non-numeric input. 3. Multiple except blocks. You can have multiple except blocks to handle different exception types. Python. Try. F equals open, myfiled, txt, r. Hashtag may raise file not found error. Data equals f.read. Except file not found error. Print, the file, myfiled, txt, does not exist. Except OS error as e. Hashtag catch other OS-related errors. Print, f, an error occurred while accessing the file. Finally, hashtag code that will always execute, optional. F.close. Hashtag ensure the file is closed even if exceptions occur. The first except block catches file not found error if the file doesn't exist. The second except block, using as e, catches any other OS-related error and stores it in the variable e for more specific error handling. 4. The else block, optional. The else block is an optional clause within the try, except structure. It executes only if no exceptions are raised within the try block. Python. Try. Number equals int, input, enter a positive number. If number equals 0, raise value error, number must be positive. Except value error as e. Print e. Else. Print f, the square of number is number asterisk number. Here, the else block executes only if the try block doesn't raise any exceptions and the number entered is positive. 5. The finally block, optional. The finally block is another optional clause that executes regardless of whether an exception is raised or not. It's commonly used for cleanup tasks like closing files or releasing resources. Python. Try. F equals open, myfiled, txt, w. F.write, hello world. Finally, F.close. Hashtag ensure the file is closed even if exceptions occur. In this example, the finally block ensures that the file is closed, even if an exception occurs during the writing process within the try block. Key points. Exception handling helps write robust code that can gracefully deal with unexpected errors. The try, except block is the foundation for exception handling. You can catch specific exceptions or use a general except clause. The else block executes only if no exceptions occur in the try block. The finally block always executes, regardless of exceptions, and is useful for cleanup tasks. By effectively using exception handling techniques, you can improve the reliability and maintainability of your Python applications. Here's a detailed explanation of how to define functions in Python. 1. Purpose of functions. Functions are reusable blocks of code that perform specific tasks. They promote code modularity, reusability, and readability by encapsulating logic into well-defined units. 2. Basic syntax. Python. Def function _name, parameters. Function docstring, optional. Hashtag function body, statements to be executed. Return output hashtag optional, return value for the function. Explanation. A def. Keyword that declares the start of a function definition. A function _name. A descriptive name chosen by the programmer to identify the function's purpose, follows Python naming conventions. A parameters. Optional, a comma-separated list of arguments the function can accept. These arguments act as placeholders for values that will be provided when the function is called. A function docstring, optional, an optional docstring enclosed in triple quotes, providing a brief description of the function's purpose, parameters, and return value. It enhances code readability and maintainability. A hashtag function body, the indented block containing the statements that define the function's logic and behavior. This is where the actual work of the function is done. A return output, optional, an optional statement that specifies the value the function returns after its execution. If no return statement is present, the function implicitly returns none. 3. Calling a function. Once a function is defined, you can call it by using its name followed by parentheses. If the function takes arguments, you provide the actual values within the parentheses when calling it. These values are passed to the function's parameters. Python. Def greet, name. Greets the person by name. Return f, hello, name. Hashtag calling the function with an argument. Message equals greet, Alice. Print, message, hashtag output, hello, Alice. 4. Example with arguments and return value. Python. Def calculate underscore area, length, width. Calculates the area of a rectangle. Area equals length asterisk width. Return area. Rectangle underscore area equals calculate underscore area, 5, 3. Print, f, area of rectangle, a rectangle underscore area, hashtag output, area of rectangle, 15. 5. Function scope. Variables defined within a function are local to that function and cannot be accessed directly from outside the function scope. This helps prevent naming conflicts and promotes data encapsulation. In conclusion, defining functions is a fundamental concept in Python programming. By effectively using functions, you can create well-structured, maintainable, and reusable code. Additional tips. Choose meaningful function names that reflect their purpose. Use docstrings to document your functions for better code understanding. Break down complex logic into smaller, well-defined functions for improved readability. Consider using default arguments to provide optional values for function parameters. A lambda function in Python is a small anonymous function defined with the lambda keyword. Lambda functions can have any number of arguments, but only one expression. They are syntactically restricted to a single expression and are used primarily for creating small, throwaway functions without needing to formally define them using the def keyword. Syntax. The syntax for a lambda function is, as shown in below image. A lambda. This keyword is used to define a lambda function. Arguments. A comma-separated list of arguments, similar to those of a normal function. Expression. A single expression that is evaluated and returned. Example. Here's a simple example of a lambda function, as shown in below image. In this example, a lambda x, y, defines a function that takes two arguments, x and y. X plus y is the expression that gets evaluated and returned. Characteristics of lambda functions. 1. Anonymous. Lambda functions are anonymous, meaning they are not bound to a name unless assigned to a variable. 2. Single expression. They are limited to a single expression, which is evaluated and returned. 3. Inline use. Commonly used in places where small functions are needed for a short duration, like inside another function, or as arguments to higher-order functions. Use cases. 1. Short-term use. Lambda functions are handy for short-term use, where defining a full function would be overkill. 2. Higher-order functions, often used with functions like map, filter, and sorted, that take another function as an argument. Examples with higher-order functions. Map applies a function to all items in an input list, as shown in below image. A filter filters items in a list based on a condition, as shown in below image. A sorted sorts items in a list based on a key function, as shown in below image. Limitations. 1. Readability. Complex lambda functions can be difficult to read and understand. 2. Single expression. Limited to a single expression, which can restrict their use for more complex logic. 3. No annotations. Lack support for function annotations, which can aid in understanding and documentation. Comparison with regular functions. A lambda function, as shown in below image. A regular function, as shown in below image. While lambda functions provide a concise way to create small functions, regular functions, using def, are more versatile and readable, especially for more complex logic. Conclusion. Lambda functions in Python are a powerful tool for creating small, anonymous functions quickly. They are particularly useful for short-term tasks and functional programming styles, such as when working with higher-order functions. However, due to their limitations, they are best suited for simple operations and should be used judiciously to maintain code readability and maintainability. In Python's exception handling mechanism, the finally block serves a crucial purpose. It's a code block that executes regardless of whether an exception is raised or not, even if the try block encounters errors or the except block handles them successfully. Here's a detailed breakdown of the finally block's role. 1. Guaranteed execution. The finally block is always executed, irrespective of the execution flow within the try. Except structure. This ensures that essential cleanup code runs even in unexpected situations. 2. Resource management. The finally block is commonly used for resource management tasks like closing files, releasing database connections, cleaning up temporary files, releasing network resources, sockets, etc. 3. Maintaining code consistency. By placing resource management code in the finally block, you guarantee its execution, preventing resource leaks or unexpected program behavior, even during exceptions. 4. Error handling with finally, less common. In rare cases, you can use finally for specific error handling scenarios. For instance, you might want to log an error message even if an exception is already being handled by the except block. However, this is generally less common than using it for resource management. 5. Example. Python. Def write_to_file, file name, data. Try. With open, file name, w, as f.write data. Except file not found error. Print f error, file, a file name, not found. Finally, hashtag ensure the file is closed even if exceptions occur. If f, hashtag check if f is open, might not be in case of exceptions. F.close. Write_to_file, myfiled, txt, hello world. In this example, the try block opens a file for writing. The except block handles file not found error if the file doesn't exist. The finally block ensures that the file is closed, even if an exception occurs during the try block or the except block doesn't execute, e.g., if there's a different exception type. Key points. The finally block is essential for ensuring proper resource management and code cleanup within exception handling. It guarantees execution regardless of exception handling within the try, except structure. It's primarily used for resource management tasks like closing files or releasing connections. In rare cases, it can be used for specific error handling scenarios. By effectively utilizing the finally block, you can write more robust and reliable Python code that handles exceptions gracefully and avoids resource leaks. If you enjoyed this video, please subscribe to my channel for more content.